So this is on page 8 of your unit handout. We're going to be spending 2 days with arithmetic series. The difference between the words sequence and series is significant. So this is on page 8 of our unit handout. And this is different. It's connected to what we've been talking about, but it's different. We need to define today an arithmetic series, find sums of arithmetic series, and then whenever I say in this course apply something, I mean we're talking about taking a word problem, like the one we just went over. That's an application of an arithmetic sequence. So now we're going to be looking at applying arithmetic series. An arithmetic series, put simply, is the sum of the terms of an arithmetic sequence. Okay? So if you take the terms, the values, the numbers that form an arithmetic sequence and you add them together, then we can call that sum an arithmetic series. So in a sequence, you separate all of the terms by commas, but in a series, we separate them by addition signs. And we use the notation S sub n to tell us the sum of n terms. So I'll show you this in detail in a second, but if I say that you need to find S5, I'm asking you to add together the first 5 terms. Whereas if I say what's T5, I'm just asking you what's the 5th term. So for example, 1, 3, 5 is an arithmetic sequence, but 1 plus 3 plus 5 plus etc., that's an arithmetic series. I'm not going to ask you on an exam to define things, but if you don't understand the language, you might have a problem from time to time. So I want to go back to this. Sn is the sum of n terms. And this is not in your handout. You can just relax and pay attention up here. If I give you this series, even though this is a series, I can still say T1 is 3, and T2 is 7, and T3 is 11. I can say all of this, right? But I can also talk about S. So if I say T1 is 3, what is S1? Well, it's 3. It's the sum of the first term of the series. If I look at this and I say T1 is 7, what's S2? 10, right? I'm adding together the first 2 terms. If the third term is 11, by the way, this is something that will be helpful later. To find S3, I don't have to add these things together. To find S3, and I want you to really think about this, I can add these things together. I can take S2, which is the sum up to the second term, and add the third term. And this goes on and on. Similarly, if I want to find S6, the sum of the first 6 terms, I can either add these 6 terms together, or I can add these 2 numbers together. Because S5 is already adding the first 5 terms. Are you getting the idea here that S is a running total, whereas T is simply the value at that point that you're going to be adding next time? Okay. So find S5 and S10. And you know what? One of these days I'm going to change my note package. I think you know what's involved in finding S10, right? We would have to write out all of the terms up to S10 so we could add them together. So the next one would be, I guess, 14, then 17, then 20. You know how we would do that. That's not what we're going to do. So let's leave S10 out of it. Okay. So what is S5? Well, S5, by definition, is T1 plus T2 plus T3 plus T4 plus T5. And unfortunately, we don't have T5, but a little bit of inspection and thought tells us that the common difference here is 3. Are we all in agreement on that? So if I add 3 to the 4th term, that will give me 14. So now I can add them up. And I'm not going to write 2 plus 5 plus 8 plus 11 plus 14. It's already there. I think I get 40. Yeah? Good. So S5 is 40. If I asked you, looking at this series, to find T100, not S100, T100, just the 100th term, would you agree that it'd be better to use a formula rather than to write out all those terms? Okay, so that's what I'm getting at here. Sometimes this process can become tedious, cumbersome, a lot of unnecessary work, and we have a formula for it. Well, we're going to, in this next set of questions, develop a formula for the sum. Find the sum of the first 100 numbers of the sequence 1, 2, 3, etc. This is actually a problem that there's a famous mathematician from, I want to say the 1600s, Leonard Euler. His name is spelled E-U-L-E-R. Developed a lot of math theorems that we still use today. And when he was in elementary school, he probably would have been about 8 or 10 years old. He tended to be unfocused because the math was easy to him. And this is a problem that his instructor gave him to try to keep him quiet for a while. And he had the answer within about 30 seconds. Because he came up with a very ingenious way to do it. So what we want to find is S100, which is 1 plus 2. The lines are here to keep me organized. You're going to have to do your best on unlined paper. And believe me, I'm not going to write out all the way up to 100. I'm going to go plus 3, plus, we'll put an ellipsis in here, which just means there's a bunch of stuff I'm not writing down. And let's go plus 98, plus 99, plus 100. This is the goal. This is what Leonard Euler wants to determine the value of, the sum of all of those things. But he thought about it for a little bit, and he realized that if he were to rewrite this series, whether it was called a series or not back then doesn't matter, in reverse order, and line up the terms, when you add them, you always get 101. If I were to take this 1 and this 100 and add them, I get 101. And if I were to take this 99 and this 1 and add them, I get 101. All the way down the line, you're going to get 101. And honestly, if somebody hadn't shown me this at some point, I remember being taught this, and said, okay, Mr. Way, find the sum of those numbers. I mean, I might stumble upon this, but I'd probably end up just adding them together. And by the way, we're talking 1600s, there's no calculators. I mean, how did you add numbers back then? You added them. Or you could multiply if it was appropriate. Now, the thing I want you to understand here is that this total is not S100. It's 2 times S100. If I were to add all of these together, I'm getting twice the sum of all of those numbers. I'm not getting the sum of all of those numbers. And the thing that, as well, you need to understand to finish this problem is to recognize that there are (100) of these things. Right? There's 101 and 101 and 101. It happens 100 times because if you look up top, we've got 100 terms. And that means that this sum is equal to 100 times 101. Well, the beautiful thing about working in decimal form is when you multiply something by powers of 10, you just move the decimal place. So 101 times 100 is this. Now, how do we go from that to the answer to the question? Because don't forget, this is what Euler has been asked to find S100. Well, divide it by 2. Look at this equation. We want to get S100 by itself. Divide both sides of the equation by 2. And you get S100. Well, don't worry about long division or anything here. This is 10,100. Half of 10,000 is 5,000, and half of 100 is 50. So it's 5,050. It's 50-50. No, we don't want to do this every time. We want to learn from Euler's brilliance. And you recognize that this number here is the first term plus the last term. And this number is how many terms you're adding. So if you know the first term of an arithmetic sequence and you know the last term, and you want to find the sum, then you add the first and the last and you divide by, or you multiply by the sum. But then we have to divide by 2, right? So there's more going on here. Another way to look at this, everybody, is if I take this 100 times 101 and I divide it by 2, it becomes 50 times 101. If you take the sum of the first and the last terms and multiply by half the number of terms, you will then get the sum. So, write a general formula for Sn. Take half the number of terms and multiply that by the sum of the first term plus the last term. Now there's something here that's going to throw some of you. Okay? But the last term is called Tn, and it's called Tn for a reason. Let's say, and I really don't want you to write this next bit of business down. Let's say I ask you to find S40 in a sequence. Would you agree that this is asking us to find the sum of the first 40 terms? So how many terms are there? 40. Which term will be the last term? The 40th term. So if you're finding S sub 40, you're going to have T1 plus T sub 40. T sub 40 is simply the last term. Anytime you see T sub n in a context of S sub n, T sub n is the last term. So this is a formula. It's a formula that you can use to find the sum of the terms. Whoops. Number 4. Use this, so let's rewrite this down, S sub n equals n over 2 times T1 plus Tn use that along with the fact that the last term can always be found using the general term formula to come up with a different way to calculate Sn. And all I am going to do, everybody, is that part that's highlighted is going to go here. Because that's what Tn is. Tn is the first term plus n minus 1 common differences. So if I do that, I get n over 2, and then I have T1 plus Tn, which is T1 plus n minus 1 times d. Once again, everybody, I could just give you the formulas because we're learning how to use formulas to find sums of arithmetic series. But when I'm doing this question number 4, I'm teaching you math, not sequences. Okay? We're building those algebraic muscles that we need in our brains. And at every opportunity, it might not be that we're learning about a specific thing in math, we're just learning math. Okay? So let's simplify this. I guess I went a little overboard with the size of my brackets. S sub n equals n over 2 times, I have T1 plus T1, which is 2T1. there is nothing to be gained by multiplying the n minus 1 by d. There really isn't, because ultimately you would use this formula by putting in a number for n, and then it will become 1 less, and you'll multiply it by d. So we have these two formulas. If you take a look, I believe it's set up so that now we're looking at the top of the next page, that we can use based on Euler's work and based on the general term formula that we can use to find sums of sequences that are arithmetic. I want you to note, though, that you always need to know n. Always. I mean, you cannot find the sum of an arithmetic sequence, or series rather, unless you know how many terms you're adding. Because n appears in both formulas, no matter what. But I want you to notice that in the formula on the right, you actually don't need to know the last term. If you know the common difference in the first term, you can find the sum of any of the numbers of terms. So let's take a look at the first set of examples. Find S12 for this arithmetic series. Okay, first of all, is it arithmetic? Just take a minute. Is it arithmetic? Plus 4, it's arithmetic. Is it a series? Well, yeah, because it's plus. Sometimes it won't be plus and it will just still say find S12. That just means find the sum of the terms. That's okay. So what do we know? I'm not a big fan of making itemized lists all the time. I think it can slow us down later on. But just to give you maybe something, I know Mr. Hetlinger likes to use itemized lists. I think Mr. Flynn does as well. Let's just summarize what we know over there. Okay? And we're also going to put in our list what we're trying to find. Now this is interesting, because if we're trying to find S12, then that means we have to use n equals 12, right? So we actually know in this question, the two parameters that define the series are t1 is 2 and d is 4, but we also know we have to use n equals 12 because we're trying to find s sub 12. So with this formula, this is the first term, and this is the last term. Look at question 1a. Do we know the first term? Do we know the last term? We don't. Nowhere does it say what the last term is. We know that the last term will be the 12th term, but we don't know the value of it. We don't know T12. So my approach, and I will show you a different approach in a second, is to say I'm going to use this formula. Now, I just prefer using the formula that takes me to the answer in one fell swoop. Takes me to the answer right away. So I put in all of the numbers. It's this simple. I go S12 equals 12 over 2, and then in brackets 2 times T1, which happens to be 2, plus n minus 1. I mentioned this the other day. I so want to just write the number 11 here, right? Because n is 12. Why don't we just put 11? But invariably, if I do that, people get confused. Somebody might get confused. So I have to figure out what this is. And at this point in time, I just want you to take a minute and find the answer to that using your calculator, or if you can do it in your head, that's great. Pretty sure it's 288. So I wouldn't do anything fancy here. I'm really not a fan of students putting all of this in brackets with everything. And you just go, well, 4 plus 44. I mean, you can figure out what these are. 12 minus 1 is 11. 11 times 4 is 44. 44 plus 4 is 48 times 6. If you have to enter it all in item by item, that's fine. So I get 288. And you can trust me that if you were to add up all of these terms, if you were to write out the first 12 terms and add them up, you're going to get 288. Okay? Now, there are some people, and this is fine, I don't have a problem with this, but there are some people who will not do that. Instead, what they will do is they glom on to this formula in their head. They really like this formula. They would much rather use this formula all the time rather than the other one. And that's going to cause problems later for some people. So their strategy then is, I need to find the 12th term. I should put t sub n here really, but you understand since n is 12, it's going to be the 12th term. So what they will do is take a detour using this formula to find the 12th term. So they will say my general term will be the first term plus n minus 1 common differences. Please stay with me here. Listen carefully. Do you agree that I typically want you to multiply this out and simplify it? I hope you also agree there's nothing to be gained by doing that here. If all you want to do is find the 12th term, why don't you just put 12 in? Right? I'm not asking you for the general term. We need the 12th term. So if I do that, I get 46. I hope, I think. Please don't let me be alone on this. I mean, you guys have calculators and brains. Pretty sure it's 46. So, what if we take the first and the last terms and add them together and multiply by 12 over 2? Well, that would be 46 plus 2, which is 48. Go ahead and take 48 times 12 over 2. You're going to get 288. I hope, yeah. I just don't like that. To me, that's an extra step. If I want to get inside of a house and there's a door that I unlock and I get in the house, why would I go around to the backyard, unlock the outer door so that I could then unlock the inner door so I can get in the house? There's one way to get in directly, I would do that. Let's just try a couple more here. This is definitely a case where if we want to find S14, we're going to use n equals 14, T1 equals 12, D equals negative 5. Definitely a case where I would use formula 2 and just put the numbers in. You have this formula right on the top of this page we're working on. I'm not going to rewrite it. S14 will be n over 2, and then in brackets 2 times T1 plus n minus 1, which would be 14 minus 1 times D, which is negative 5. I like that set of brackets I put around the negative, and you should too. You should put that there. Sorry about that. That's the stress and the pressure of being in elementary school and teachers asking you to do that, and if you didn't get the right answer, back then they'd smack you on the hand with a ruler. I'm just kidding. They hit you on the head with the ruler. Any questions with getting negative 287? Okay. All right, and finally, there's nothing wrong with working in decimals here. T1 is 0.25, D is 0.5, N is 9. Pretty straightforward. S9 is 9 over 2 times 2 times 0.25 plus 9 minus 1 times 0.5. I'm going to pause there. Is everybody okay with me saying T1 is 0.25 and D is 0.5? Okay. So take a minute and figure out what that is. 81 over 4, I guess. 21.25. So are we okay with using this formula? Let's try a different kind of problem though. What is the sum of this series? So we know the first and the last terms here. So the first term is 5. The last term is 295. We don't know n. And you need to know n to answer these questions. You cannot find a sum unless you know n. So this is a question that would have been on your quiz yesterday. It would have said, an arithmetic sequence is given by this, how many terms are there? That was question number 2 on your quiz. The numbers were different. So how do we do that? We recognize that if we find the value of n that will give us 295, that value of n will be how many terms there are. Because if n is, for example, 13, I don't know what it is, doesn't matter. If n happens to be 13, then we're saying T13 is 295, which means 295 is the 13th term. But that's the last term, so there must be 13 terms. And we solve this problem by using our general term formula and putting in the first term and the common difference. So this is a detour. Now, again, everybody, normally I would say you multiply this out. We don't need to. We can just go ahead and put 295 here and solve for n. And how I would do this is I would subtract 5 from both sides. I wouldn't even multiply that out. I would simply divide by 10. You could multiply it out and go from there. But I would divide both sides by 10 and add 1 to both sides. So there's 30 terms. The 30th term is 295, which means there's 30 terms that we're adding together. So now we do know n, and we can use this formula. N is 30. S30 is the n over 2 times the first term plus the last term. Let's do one more like this. We probably won't do all of them. Let's jump down to C where we have fractions or decimals. So we're going to forego B. The first term, we want to find Sn. It will be n over 2 times the first term plus the last term. Right? That's the formula. But we don't know n. We don't know n. So we take a detour into T sub n, which is the first term. Correct me if I'm wrong. 2 over 5 is 0.4. Plus n minus 1 times the common difference of 0.2. You can confirm this by taking 3 over 5 and getting 0.6. 4 over 5 is 0.8. It's going up by 0.2 each time. And we want to know how to get 10. We want to know which term has a value of 10. So I'm going to give everybody a minute to solve that equation for n. You're going to have to subtract and divide and worry about adding something at the end. Put up your hand and hand up and down if you have it already. Don't try to do it in your head like me. Just use your calculator. You got it? 49? Yeah. I'm getting 49. So you're taking 10 and subtracting 0.4 to get 9.6. When you use your calculator and you take 9.6 divided by 0.2, you're going to get 48. Add 1, you get 49. So we're finding S49. It'll give you a minute to finish the question. $254.8. You want to impress your family, your friends, your pets. Get your math key and go enter, enter. It's 1,274 fifths, which who cares? Right? So later today you're going to have some problems where there will be decimals involved. I don't care if you get the exact answer as fractions. Decimals is fine. All right, there's one more thing I want to do with you today. It'll take about 5 minutes, and you'll have between 10 and 15 minutes to practice some of these on your own. So running drills at practice, a coach puts 10 pylons in a line and spaces them 5 meters apart. An athlete starts 8 meters away from the first pylon. Coach blows the whistle, and the athlete has to run from their position to the first pylon and back, and then from the beginning again to the second pylon and back, and from the beginning to the third pylon and back, until they end up going to the 10th pylon and back, and they've completed it. It says the first term of the sequence is the distance traveled to the first pylon and back. The second term is to the second pylon and back, so on and so on. Now, why is this arithmetic? Well, if I run from the first pylon and then back, and that's the first term, I hope you would agree that it's 16 meters. Now, how far is it from the beginning to the second pylon and back? Well, I have to go 13 meters, 5 plus 8, and then 13 meters back, which is 26. I hope before I even proceed that you understand the common difference will be 10 meters, because each time you repeat this exercise, you have to go an additional 5 meters in one direction and an additional 5 meters in the other. Right? But we could do this. We could go for the third, 8 plus 5 plus 5 plus 5 plus 5 plus 8. You're going to get 36. So this is what's going on here. You have, and this is true whether we're talking about a sequence or a series, it doesn't matter. We have the first term is 16 and the common difference is 10. We've translated the word problem into a numerical problem, which is always helpful. What's the difference between Tn and Sn? Well, Sn is a running total of how far the person has gone after n trips, whereas Tn is how far they're going in that particular trip. So as an illustration here, T4 is from the beginning no, I don't care if I've spelled it wrong. From the beginning to pylon 4 and back. That's it. S4 is the total up to pylon 4 and back. I mean, I don't think I need to spend class time writing. It's the sum of pylon 1 and back and pylon 2 and back and 3 and back and 4 and back. It's the running total. So be very careful when you answer these word problems, because sometimes you might be asked for the term and sometimes you might be asked for the sum. Find an expression for t sub n. Okay. T sub n is the first term. So if you apply the general term formula, you take the first term, which is 16 plus n minus 1 times d. We might as well simplify this. I don't think we need to write down what it means. It means how far you travel from the beginning to a particular pylon and back. So S8 is the distance, or T8 is the distance from the beginning to the 8th pylon and back. I'm going to forget about C. Don't do C. I don't want you to do C. What is the total distance run by the athlete during the exercise? Would you agree, since there's 10 pylons, there's 10 there and backs? So do we want to find T10? Is that what this question is asking? S10, right? We want to find S10. So I would use this formula. And put the numbers in. S10 is 10 over 2. 2 times 16. I want to make sure I get it right this time. 16. Plus 10 minus 1 times d is 10. Thank you. And you work out what this is. I mean, you just have to crunch some numbers at this point. It's not even high school math. How does 610 sound? Good. So it's a total of 610 meters. 6/10 of a kilometer. It's a good exercise. I notice this says C. Did you actually have that other C, or was it just you did, eh? Was this labeled D? CC? Okay. I got some work to do on this lesson. That's fine. So 1, 2, and 3 in your textbook and question 9 are 4 word problems. Well, 2 word problems, I think, and then 2 problems where you have to find sums. With 1 and 2, I'll just show them to you. There's 1, there's 2, actually 1, 2, and 3. I think if you did every second question, that's more than sufficient. So if you just do A and C on these, that's good. You don't need to do every one. This is a kind of a situation where I would tell my students, I don't care what you do for homework in this particular case. You have to know how to do them. So do a couple from each. And then number 9 is probably, same kind of thing like the pylon question. I don't have a lot of time left. It depends on which clock we're looking at, but you have enough time to get started.